Section 6.3 Systems of Nonlinear Equation. So in this section we're going to take a look at systems again. Once again, we did that in the last two sections, except in this time the system contains nonlinear equations. Nonlinear means degree other than 1. Okay, degree other than 1. Okay, now both equations don't have to be nonlinear, but one of them has to be nonlinear. Okay, so and the way to solve a nonlinear system, you have two methods. Okay, 90% of the time you use substitution. Remember substitution from section 6.1, and once in a while you use elimination. I'll write down when. You use elimination for nonlinear systems if the variable terms in the two equations I'm sorry, let me write this way. The two equations have like variables. That means they have the same variables. Okay, that's the only time you use elimination, or else we always use substitution. So majority of the time we'll use substitution. Just once in a while when the two equations have like variables, by that I mean is like you have ax squared plus by squared is equal to c, and dx squared plus ey squared is equal to f, where a, b, c, d, e, and f are numbers. So these are like variables. So the two equations have x squareds and the two equations have y squareds. So in that case, if they have the like variables, then we can use elimination. But if they don't, then we always use substitution. And you can see this is nonlinear because the degree is 2. And I do want to stress this, both equations don't have to be nonlinear for a system to be nonlinear. Only one equation has to be nonlinear for the system to be nonlinear. So let's get started. Now that we know what method we need to use, we just need to take a look at some examples. Okay, if you remember, when we had a system of two variables, each equation represented a line. So we were looking for points of intersection. We're doing the same thing over here. So let me get started by giving you an example first. Okay, a simple example, and then we'll move on. Let's say if you have 2x plus y is equal to 1, and we have x times y is equal to 4. Okay, actually let's make it a 1, 2. So this is equation 1 and equation 2. Now you don't need to know the graphs of these, but it does help sometimes to understand what's going on. Okay, the first equation is just a line. So let me go ahead and graph that line as accurately as I can, just to show you what we're looking for. Okay, the x-intercept, let's make this a 2. So the x-intercept is 1 and the y-intercept is 2. So this line looks like this. Okay, now this equation, so this is 1 and 2. Okay, let me change this, actually make this a 4. That doesn't help. I will make it, that might help. There we go. Let's try that. Okay, if x-intercept is 1 and the y-intercept will be negative 2, so the line goes like this. Okay, so that's the graph of the first equation. What's a graph of the second equation? It is xy is equal to 1. So let's solve for y. Divide both sides by x, so you get 1 over x. Okay, so now we graph this. We can do it exactly the same way we did rational functions in chapter 4. We find the x and the y intercepts, and then we find asymptotes and things like that, because it's a rational function, it's a fraction. And if you went through all of that, you would find that the graph looks something like this. Okay, so that's what that graph looks like. So how many places do the first two equations cross at? Okay, they cross at 2 points. They intersect, I'm sorry, not cross, they intersect at 2 points, and those are the 2 points we are looking for. Okay, so there's 2 points of intersection. You can see that from the picture, so it does help sometimes to have a visual idea on what's going on. Okay, so now let's go ahead and see if we can find those 2 points. Okay, so we're going to use substitution. What does substitution tell us to do from 6.1? We pick any one of the equations and solve for one of the variables, doesn't matter which one. And I told you before, it's always a good choice is to pick an equation and solve for the variable that doesn't give you fractions. But sometimes you cannot avoid them, but if you can, always do that. So in this case, I'm going to pick 1 and solve for x. I'm sorry, solve for y. So what does 1 become? So let's write down 1. It is 2x minus y is equal to 2. So I'm going to move the y here and the 2 on the other side. So we get y is equal to 2x minus 2. So now I know y. So what do we do next? We substitute y into the other equation, so into 2. So this is how we did substitution in a couple sections ago. So what does 2 become now? 2 was what? xy is equal to 1. That's what 2 was. So we replace this y with this. So we get x times 2x minus 2 is equal to 1. Okay. Now the whole idea of substitution was to make it into one equation with one unknown. So we only have one unknown. If I distribute this, I'll get x squared. So we have a quadratic on our hands. So we always want to move everything to one side when we have a quadratic. Okay. So I move the 1 to the left. And this cannot be factored, so we'll have to use the quadratic formula. We're solving for x, so we get x is equal to minus b plus or minus square root of b squared minus 4ac divided by 2a. Okay, so we have that. So we get a is 2, b is negative 2, and c is negative 1. So you get negative of negative 2 plus or minus square root of negative 2 squared minus 4 times 2 times negative 1 over 2 times 2. So we get 2 plus or minus square root of negative 2 squared is 4. Negative 4 times 2 is negative 8. Negative 8 times negative 1 is positive 8 over 4. So we get 2 plus or minus square root of 12 over 4. Okay. So we get 2 plus or minus 2 square root of 3 over 4, because that's what square root of 12 is. And you can divide each of these by 4. So we get 1/2 plus or minus square root of 3 over 2. So those are my x values, and I got 2 of them, and that makes sense because if you look at the graph, for some x it crosses here, and then for another x it crosses here. So there's 2 x values. Do you guys see that? For which it crosses. So there we expect 2 of them. We found 2 of them. We can change them into a decimal, but it's better to leave it like this. Now how do I find y once I know x? Well, we know y from 1 when we did the first step here. Not from 1, but when we did the first step here, we know what y is, right? It's 2x minus 2. So let's do that. So we have y is equal to 2x minus 2. So if x is, we have to do each one separately. If x is 1/2 plus square root of 3 over 2, then what is y then? Y must be 2 times x. So it'll be 1/2 plus square root of 3 over 2 minus 2. So remember that you have 2 terms here to put parentheses, so we distribute this. So we get 2 times half is just 1. When you multiply these two, the 2's will cancel, so you get square root of 3 minus 2. So you get negative 1 plus square root of 3. So my first point of intersection is x is 1/2 plus square root of 3 over 2, and y is minus 1 plus square root of 3. So that's one point. I still have another one to find when x is minus, so let's do that. 1/2 minus square root of 3 over 2. So what is y? y is 2 times 1/2 minus square root of 3 over 2 minus 2. So we distribute this. So we get 1 minus square root of 3 minus 2. So we get negative 1 minus square root of 3. So this time we get x is 1/2 minus square root of 3 over 2, and y is minus 1 minus square root of 3. And there you go, we found our 2 points. Okay, so that's how we solve these nonlinear systems. We just do it by substitution. It helps to know what's going on with the picture, but if you cannot, that's not a big deal, but it does help. Here's another example. Let's say if I have x squared plus y squared is equal to 10, and we have 2x plus y is equal to 1. So once again I have two equations. This is nonlinear because the degree is 2. By the way, why was this nonlinear? The degree over here was 1, so that's linear. But this one, because this is 1 and 1, when we talk about polynomials, to find the degree of the polynomial term, we add the exponent. So 1 plus 1 is 2. So that's why this is nonlinear, because of this guy. Okay? Alright. In this case, I'm hoping, I truly am hoping you guys recognize the first equation. Anytime you have x squared plus y squared is equal to this, that should look familiar. It should be something like this, right? Except h and k in this case is 0, they're not present. So the center is at 0, 0, and the radius is r squared is 10, so the radius is square root of 10. So I hope you recognize that really is an equation of a circle centered at the origin. So in this case, the graph looks like this. It is a circle centered at the origin and has a radius of 3 point something, a little bit bigger than 3. Okay, and then this is just a line. The y-intercept is 1. Okay, and the x-intercept is 1/2. Okay, so it's a line that goes like this. So we're looking for points of intersection. Once again, we have 2 points of intersection. So let's find those. Okay, so in this case, what do we do again? We pick one of the equations and solve for one of the variables. So in this case, I'm going to pick the second one this time. We always do substitution unless we have like term variables. Pick 2 and solve for y. So what is 2 then? We get 2x plus y is equal to 1, so we get y is equal to 1 minus 2x. I just moved the 2x to the right hand side to get that. Now that we have y, what do we do next? We substitute y into the other equation, right? Into 1. So what does 1 become? Well, 1 was x squared plus y squared was equal to 10. So I'm going to replace this y with this. So we get x squared plus, there's 2 terms here, so we need to put parentheses. Squared is equal to 10. Now I want to solve for x. It became an equation with one unknown, right? Can we solve for x? Sure, we can solve for x. What do we need to do? Well, I need to expand this. So you can do it in 2 ways. You can take 1 minus 2x and multiply it by 1 minus 2x and do it. Or you can use the binomial formula. Do you remember you have 2 terms squared? The binomial squared formula that I gave you a long time ago. So I'm going to use that this time. You get x squared plus the square of the first, so we get 1. And then you get the product of the first and the second. So 2x times 1 is 2x times 2, so we get plus 4x, except because there's a negative in the middle, it'll be minus 4x, plus the square of the last term, which is 4x squared, because 2x times 2x is 4x squared, is equal to 10. So I can add these two terms, so I get 5x squared, okay, minus 4x, and since it's a quadratic, I'm going to move the 10 to the other side, so it'll become a negative 10. Negative 10 plus 1 is negative 9 is equal to 0. Now this is a quadratic. We can use a quadratic formula like we did in the last problem, or in this one I can actually factor, because we want 2 numbers. It's an AC method, 3 terms, nothing in common, so we use the AC method. There's a 5 in the front, so I'm putting 5 everywhere. I want two numbers. When I multiply, I get 5 times negative 9 is negative 45, and when you add, we get negative 4. So you can clearly see the numbers are negative 9 and 5, negative 9 plus 5. So you get negative 9 plus 5. I can take out a 5 from the last term there. So I get x plus 1 is equal to 0. There's a 5 here, so that will cancel. And you can do this factoring on the side if you like, which is what I would recommend. Okay, so this product is 0 now, so that tells me one of them is 0, so I get 5x minus 9 is 0, and x plus 1 is 0. So I get x is equal to 9/5, and I get x is equal to minus 1. I got two values of x, and we expected that from the picture, right? When x is minus 1, here you'll get 1, and the other one was what? 9/5, so it's roughly 1.8. So it'll be 1, 2, so it'll be 1.8 here. Okay, so you can see we got two x values. Now we have to find the y values. Well, that's not difficult because we know y from up here, don't we? In the first step, what is y? 1 minus 2x. So let's start with that. So y is equal to 1 minus 2x. So if x is equal to 9/5, what is y? 1 minus 2 times 9/5. So you get 1 minus 18/5. So we need a common denominator, which is 5. So we get 5 over 5 minus 18/5. So we get negative 13 over 5. Okay, so that's one answer. What happens if x is minus 1 then? We plug it into our y. Y is 1 minus 2 times negative 1. Negative 1, put parentheses. So you get 1 plus 2, so we end up with 3. Okay, so what are my solutions? If x is 9/5, y is negative 13/5, that's 1 point. And if x is minus 1, y is 3. So I got two solutions. Okay, and you saw that from the picture there were 2 points of intersection for that problem. So just, if you, like I said, if you can draw the picture, it's really nice because you can visualize what's going on. But if you cannot draw the picture, it's not a big deal, but it does help to draw the picture. Okay, all right, let's take a look at two more examples and then we should be done. We have a system like this. We have 2x squared plus y squared is equal to 24, and we have x squared minus y squared is equal to negative 12. Now, just for your information, we didn't do ellipses or hyperbola, but this is a graph of an ellipse. Ellipse is like an oval, and this is a graph of a hyperbola. Hyperbola is kind of like two parabolas. Okay, so if you look at it, this is what it looks like, just to visualize. It's like a parabola. Hyperbola has two halves, so that's a hyperbola, and my ellipse would look something like this, an oval. So how many points of intersection do I have here? 1, 2, 3, and 4. Now I could have had a picture like this. This could be the ellipse, this could be the ellipse, this could be the this could be the hyperbola, ellipse. Do they intersect? No, in that case we have no solution, but in this case they intersect at 4 points. So let's find them. Now this time, if you notice, I'm going to call this 1 and 2. This time we have like term variables, x squared, y squared, y squared. So I can use elimination. This is the only time I can use elimination. And it's already set up for elimination because I already have plus y squared minus y squared. So I can just cancel those. So I get 3x squared is equal to 12. So you divide both sides by 3. So you get x squared is equal to 4. We have a square and a number, so we can take square roots. So we get x is equal to plus or minus, don't forget that, 2. So we got two values of x. So now all we have to do is find y. So how do I find y? We take this x and plug it into any one of those original equations. So it doesn't matter. I'm going to plug it into 2. So 2 tells us what? We have x squared minus y squared is equal to negative 12. So if you move this there, we get y squared is equal to x squared plus 12. Okay, so now we know that. Or we can solve for y. Y is what? When you take square roots on both sides, we introduce plus or minus square root of x squared plus 12. So that's what y is. So now if x is equal to plus 2, what is y then? Is equal to plus or minus square root of 2 squared plus 12. So we get plus or minus square root of 2 squared is 4. 4 plus 12 is 16. So we get plus or minus 4. So if x is 2, we get two y values. So we get when x is 2, y is 4, and when x is 2, y is negative 4. So that's two solutions. Now we also have to worry about when x is negative 2. Well, what happens? You plug it into a formula for y, we get plus or minus square root of negative 2 squared plus 12. So we get y is equal to plus or minus square root of 4 plus 12. So that looks exactly like what we have here. So it'll be plus or minus 4 again, because 4 plus 12 is 16, square root of 16 is 4. So in this case, when x is negative 2, y is 4. And when x is negative 2, y is minus 4, because we get plus or minus. That's two more answers. So we got a total of 4 points, and that's exactly what we expected. Okay, when x is 2, y is 4 and negative 4, and when x is negative 2, y is 4 and negative 4. Okay. So remember, when we can use elimination, when we have a nonlinear system and we have like variables, then we can use elimination. That's the only time we can do that. It always works out really nice. If you try to do this with substitution, it'll get a real mess. Okay. Alright, so those are examples of nonlinear systems. Let me give you one last one, and then, like I said, we'll wrap it up. Okay. Here's another nonlinear system. We have x squared minus 2y squared is equal to 2, and we have xy is equal to 2. Okay. So the first equation is a hyperbola again, except this time it opens sideways here. Okay, and then the second equation looks like what we had before. It's a it's really a hyperbola too, which opens sideways. It's rotated actually. Okay, so we have 2 points of intersections to find. So we already know how many solutions we are looking for. And like I said, if you don't know the graphs, it's not a big deal, because we haven't done hyperbolas or ellipses, but if you did know them, it does make your life a little bit easier. So this is 1, 2. Now this one's interesting. The reason why I wanted to do this one is, in all the other substitution problems, it was really evident what equation to pick and what to isolate. In this one, it's not that evident which one to pick and which one to isolate. So what do we do in this case? Well, we are going to have to pick one of them. So I could pick the first one, or I could pick the second one. It doesn't matter, but we need to pick one of them. Now what I'm going to do here is I'm going to pick the first one and then solve for x squared. Okay, so let's pick one and solve for x squared, not x, but for x squared. So what does 1 become? We get x squared minus 2y squared is equal to 2. So we get x squared is equal to 2 plus 2y squared. Now what do? We substitute that into the second one, but the second one doesn't have an x squared term. But that's easy to create though. So we can substitute x squared into 2. So this is 2. I have xy is equal to 2. So I can go ahead and square both sides because of the equality. So I get x squared y squared is equal to 2. Now I can replace this x squared with this. Do you guys follow? So that's one way to do this problem. So I get 2 plus 2y squared multiplied by y squared is equal to 2. So that's one way to do it. Or we could have done this. We could have pick 2 and solve for x. Okay, so let's do that. So I get 2 becomes what then? I have xy is equal to 2. So I divide both sides by y. So I get x is equal to 2 over y. So now what do? We substitute x into 1. So let's do that. So 1 becomes what? 1 was, we had, what was 1? X squared minus 2y squared is equal to 2. So I'm going to replace the x here with 2y. 2 over y squared minus 2y squared is equal to 2. I can square this, so I get 4 over y squared minus 2y squared is equal to 2. What do we do when we have fractions and equality? We always try to get rid of those fractions, multiply each term by the common denominator. What is the common denominator here? Y squared. So I multiply this by y squared, so the y squares will cancel, so I get 4. I multiply this by y squared, so I get negative 2. What is y squared times y squared? Y to the 4th. And I multiply this by y squared, so I get y squared. So I multiplied each term by the common denominator, so that's what I did. CD was y squared. Now if you notice, because of the equality, since I have 2's everywhere common, I can divide everything, both sides, by 2. And then I'm going to move everything to one side. I'm actually going to move everything to the right hand side. So I get y to the 4th plus y squared minus 4 is equal to 0. Okay. So that's what we end up with. And is that what we had up here? If we had distributed, we would have ended up at 2y squared plus 4y to the 4th is equal to 2. Move everything to one side and divide everything by 2 since there's a 2 common. So I get 2y to the 4th plus y squared minus 2 is equal to 0. Oops, I forgot to divide this by 2, sorry, because we want to divide everything by 2. Okay, and this should be divided by 2 because we're dividing everything by, trying to do everything in my head. That's what happens if you try to take shortcuts and do things in your head. You can make mistakes. So we get the same thing. Now, what kind of an equation is this? It doesn't matter which one I solve, they're exactly the same. So I'll solve this one. This is almost quadratic, right? I have 3 terms, and how do we check for almost quadratic? We take the middle term and we square that. So we get 2 times 2 is 4. And if that's the first term, it's almost quadratic. So we make a substitution. We go z is equal to the middle term variable, and then you square both sides again. So this tells me I want to replace y to the 4th with z squared, so I get z squared here, plus z minus 2 is equal to 0. I hope you realize that. Now I can easily factor this, so what do I get? Or can we not factor that? We get z plus 2, and we get z minus 1 is equal to 0. Okay. I'll make sure I did all of this correctly. We had, okay, so z plus 2 is 0, so z is equal to negative 2 and z is equal to 1. But what was z? Z was y squared. So when you solve for y, you're squaring a number, so you take square roots on both sides. So we get y is equal to plus or minus square root of 2i because of the negative square root. Do you guys follow? And then we get square roots on both sides, so we get y is equal to plus or minus 1. Since we're working with real numbers, okay, this doesn't come into play because we can't graph complex numbers, because that's a little bit more complicated than graphing real numbers. So y must be plus or minus 1. So we found 2 values of y, so now we have to find the corresponding value of x. So what is x? Let's go back up here. This is what x was, if you remember that. Okay, x was what? We had, okay, ouch. X was 2 over y, so let's do that. So if x is equal to 2 over y, so if y is equal to 1, then x is equal to 2, and if y is equal to minus 1, then x is equal to 2 over minus 1, so x is equal to negative 2. So what are my 2 points of intersection? X is 2, y is 1, and x is negative 2, y is negative 1. So those are my solutions. So if you go back and look at it, That's kind of like what we had for the picture. Okay, if x is 2, y is negative 1, and y is 1. So you can see if x is 2 here, y would be 1. Okay, and if x is negative 2, y would be negative 1. So kind of get the idea. Okay, so that's how we solve nonlinear systems. Okay, by substitution. The only time we use elimination is if the two equations have like term variables. Okay, have variables with like terms, and then we can use elimination. That I did an example of that. Okay, this one here where we have x squared, y squared, so the two equations have like terms. That's the only time you use elimination.